My name is Thomas Risberg. I work for Pivotal, and I'm going to talk to you today about deploying Spring Boot apps on Kubernetes. And just a show of hands, I assume you all have some experience using Spring Boot since you're on a Spring conference, but who's you done anything with Kubernetes here? Okay, so not a whole lot, a few people. All right, so let's get started. So why am I giving this talk? Well, a couple of reasons, but one reason is that I did search on Google Trends looking at some hot technologies, and it seems like Spring Boot and Kubernetes track each other pretty well. So I thought, yeah, it's a great thing. You combine them and you get even more interesting technology going. And I work on the Spring Cloud Data Flow project earlier, and right now I'm contributing on the project RIF, which is the serverless function as a service. And we did a lot of deployments on Cloud Foundry as well as Kubernetes for the Data Flow project. So that's where we started working on as deployer for working on deploying apps on Kubernetes. So that's why I thought I should share my experiences working with Kubernetes. And one thing that I like about Spring Boot is that, like Josh says in his tweet here, it lets you pair program with a Spring team, which is a great asset. And Kubernetes builds on 15 years of experience running containers at Google. So in my opinion, using Kubernetes, you're basically pair programming with Google's engineering team. So you combine these two technologies, and you get some good stuff. And looking at Kubernetes architecture, I'm not that deep into the inner workings of Kubernetes. I'm more as a user of it and deploying apps on it. And there's a talk following this talk from Megan Challen from Google, and I'm sure she'll go into more depth on how Kubernetes actually works. So stay for that talk if you're interested. And there's a control plane on the left there with the API server that we talk to when we deploy apps, and it stores all the resources you create in an etcd instance. And then there's a scheduler when deploying your apps. It schedules them on the different nodes, and the nodes are on the right there, and there's a kubelet that runs the node and actually runs your Docker containers. And then there's a proxy so you can network into the containers running. And your apps run in something that's called a pod. So if you look at it from a different perspective, look at Kubernetes works with resources primarily. So we take my little app and I put that in a jar file, my Spring Boot app, and I wrap that up into a Docker container. And so far, here we go with a pod. A pod is one or more Docker images running together. And they run in the same namespace, and they share networking so they can talk to each other if that's what you want to do. A lot of times you just deploy one Docker image. And then you wrap your pod with a replica set where you define how many instances do I want of this hello jar running at the same time. You can have one up to how many you want. So the replica set keeps track of how many replicas there are. And then you wrap that in a deployment that gives you more features, like you can scale, you can do rolling upgrades. And once the deployment is up and running, so these are the three main resources I work with when I deploy apps in Kubernetes: the deployment, replica set, and pod. And to talk to your actual applications running, they run on a node, you don't know exactly where it is. You need a service to front it so you can get a network connection to your hello jar application. And if you're multiple pods, the service can load balance across them. So whenever you hit the service, it will take one pod after another. And then you need to be able to configure your applications. So you use config maps and secrets. That's another resource that you use very often in Kubernetes. So if you connect to a database, you want to be able to provide username or passwords, things that change for each deployment. And that's done on the Docker level. So I was just going to show a quick demo. And I have links to all my demos. And since we only have 30 minutes, there's not a lot of time to go through all the details. So I wrote up a little README file for all the steps I went through to get these demos running. So these are all running on Minikube on my laptop. So Minikube is basically running in a VM on my laptop, and it's a complete Kubernetes environment there. So once you install the Minikube, you also install the kube control, which is a command line utility you use to talk to Kubernetes. So you start up the Minikube. I created a very simple boot app using the Spring Initializer web interface. And all I did was add a REST controller method here. So basically just pass back a string from an endpoint. So it's not a fancy app, but it serves its purpose to show how to deploy these things on Kubernetes. I also need a Docker file. Again, very simple, typical standard Docker file, Java app. So when I run this in Kubernetes, there's a trick where you can, instead of building Docker images, putting them up on Docker Hub, you can build them locally and build them inside the VM where the Kubernetes Minikube is running. So I just eval and then the Minikube Docker environment. And now I'm actually pointing my Docker to Minikube's environment. So when I do clean package, and then I do a Docker build, it actually built that now in the Kubernetes environment. It's a little hard to read, but you see all the Kubernetes containers here, and you should see our little hello somewhere. It's in here. There it is. So to get this running, I just use the kube control command line interface. I say run hello, and I point to the image I just built, and I tell them what port I want it to run on. So now we create a deployment so we can keep an eye on all the stuff running here. So we see we got a deployment called hello with a pod hello with some ID attached to it to make it unique. And I can't connect to that now until I create the service. So the service is the resource that lets me connect to the deployment pods. And I use the type node port because I don't need an external IP for this. If I run it on a hosted Kubernetes service, I would typically use a load balancer. And then I get a public IP, and I can actually connect to my apps up in the cloud. But this is running locally, so Minikube uses the node port. And here we see my service got started. And I got assigned the port here, which is the node port I'm going to connect to. And then Minikube also gives you the URL for your service. If you type in Minikube service, the name of the hello, and just I want the URL back. And there we see it again, the same port. And I'm ready to test the app to hit my endpoint for hello. All right, so we got our text back, hello Kubernetes. So this is very basic little app. We got it deployed, we got it running. And we can look at the actual resource definitions that Kubernetes has created for us. So there's a whole lot of everything, all the resources that Kubernetes works with are represented as YAML files. So this is a deployment and has one replica. And the service finds the pods by using labels. So I labeled everything here hello, or actually the command line did that for me. And here's the image that is running. And the image pull policy says if not present, so if it's not available already locally, it will pull it from Docker Hub. And there's a tip from Joe Beda, who worked on Kubernetes early on, to actually use a dry run of the run command. And it will actually show you what the resource looks like. And you can cut and paste this and start modifying that to the way you want it to be. So it gives you a quick start in actually being able to repeat this deployment without resorting to shell scripts. And to undeploy everything, there's a delete command for kube control. And I use the label where we said that was set the run equals hello. So that should delete the service, the deployment, and everything. Yep. So we can see here now it's terminating the pod. So if you look at the way Kubernetes works, it doesn't really enforce any specific application architecture. And it's basically, it's up to you how you want to confine or define your things, your resources. But it has a few things that you can use to configure and control everything. I mean, it's environment variables and configuration files and secrets. And you use them in your resource definitions to modify for each deployment that you want to do. And it also creates a DNS entry for every service that you have. And it will create an entry, an environment variable for every service that's running. So your app has access to all the other services that's running in the same namespace of Kubernetes. So in terms of externalized configuration, it's environment variables I use a lot. And they're easy to set in your deployment YAML. And if you have some Spring Boot map-based properties, you might need to resort to using the Spring Application JSON technique. But most of the time, it translates pretty well if you just use the uppercase, the underscore style. And you do use the config maps and secrets a lot. And you can either use them to populate environment variables, or you can mount them as a file in the file system. And boot will look at everything under the config directory. So it will find your configuration files there. Or you can also use the Spring Cloud Config Server. I typically don't find that is necessary for simpler applications. So since Kubernetes has so many ways of configuring your apps anyway. So I have this other demo, which is available here. which is more of a larger 3-piece microservice type of application. And it's basically a service that runs something called actors. So I just be able to put name and some other information about an actor, and then I have another service that runs images, so I can post images of different actors. And then I have another service that reads both and provides an API for me to access this information. And we don't have time to go through all the details here, but I build all them individually. And I have pushed up Docker images. If you go through this demo yourself, you might have to change a few of the references to match your username. And I also use something called Helm to make it easier to deploy things. So Helm is basically a package manager for Kubernetes. So if you use Linux, you know how you do apt-get install. It's a similar thing. You do Helm install and then the name of the package. And it's very handy, and I have a package for this other app, which is I'm in the wrong place. So it's basically you define templates for your resources, and then when you deploy it, it fills in the details that you want to override and specify. So every deployment, every service, every config file has a template here. And when I do install it, I just do Helm. Let's just watch the pods so we see what's going on here. So Helm install, and the name of, now I'm running this from the local disk, but there's also a Kubeapps, which is a hosted collection of applications that you can install on Kubernetes easily. We actually have a Helm chart for the for the Spring Cloud data flow, so it makes it very easy. You just say I want to install this chart, and it goes through everything, and it creates a bunch of resources and pods and services and everything for you. And you can see it takes a little while to start up a larger application, but it will come along sooner or later. Boot apps take a little time to start up in Kubernetes. And I have a README file, how I created one of these, again, step by step. And then there's also another README, how to run the microservices demo. And of course, we have the source code you can download. I just want to look at a couple of things that I did in this demo. This is the specification of the containers I'm running. So this is for the actor container. So it's basically the image name. And then I mount the volume pointing to the application config file. And I mount that under /config, which boot will look at. And I run and the bottom, you see the volume specification, and that's actually pointing to what file that's going to be available under that /config directory in the mount. So it's an application Kubernetes YAML. I named it that way because I set the boot's the profile to be Kubernetes, and that way I can run it locally using the default profile, and I can run it on Kubernetes using the Kubernetes profile. And boot, if you put application dash profile name, that's the last one that boot will, or one of the later ones that boot will load, so you can override anything that's in the other settings. And in this case, what I have in the config map is the data source configuration. And I reference the MySQL service host there, which is an environment variable that Kubernetes will provide me, because I already have MySQL running. The same thing for the port. And I also set the password as an environment variable using a secret. And that's what that looks like. The secret has a encoded password, so that's actually not actually the password, it's 64 encoded. But once you mount it as an environment variable, or you pull the value and put it as an environment variable, it will be decoded so you can actually use it. And I call the environment variable my SQL root password, which was what I referenced in there in the password property. So if you look at microservice architecture concerns, there's a number of issues you will have when you run microservices in the cloud. The configuration, we already figured out that we can use a lot of the Kubernetes features for that. Also the service discovery, we can use DNS discovery. There is circuit breakers. There's really nothing in Kubernetes itself to do that, or tracing, or metrics. Or there's log aggregation, but it's not, it's usually part of the cloud hosting company that sells you Kubernetes for what they use for their aggregation. There's some things you can use from the Spring Cloud project, which is circuit breaker. There's a Netflix historics that I've actually put that into my little microservice demo here. There's distributed tracing for Sleuth Zipkin. And there's metrics now using the Spring Boot actuator and micrometer. And another project I think you should keep an eye on is Istio, which is what they call a service mesh, which does a lot of the load balancing, routing, enforcing policies, and does also a lot of the metrics reporting. And it's getting quite popular, and I think not only for Kubernetes, but it will be in Cloud Foundry and other cloud environments. And it basically runs a sidecar in your pod, and all the networking goes through this sidecar, and it's basically a proxy, and it keeps an eye on all the traffic and routing and takes care of enforcing all the policies using that sidecar. And for log aggregation, I don't have anything in my demo. Google has Stackdriver for their hosted GKE. There are a lot of people use Elasticsearch and Kibana. Well, there's also something called Logly. So if you're interested, I have the links here. It's not part of my demo. And like I mentioned earlier, there's Helm, which is the package manager. And Cube Apps is where you can discover what apps are available to easy install if you don't want to work through to configure all the deployments and the resources for it. There's already someone figured out how to do it. And I have an example chart in my microservices demo app. And there's another project from the Fabric 8 team. They created something called Spring Cloud Kubernetes. which has a discovery client that has a config map and secrets. So it actually will look for you specify what config maps or secrets you want to include, and it will create a property source for you, so you don't have to do all the mounting and everything that I did in my example. The reason I didn't use it for my demo is because it doesn't support Spring Boot 2.0 yet, but that support is coming. So it works with 1.5 based boot apps. And it's now part of Spring Cloud Incubator on GitHub. And it looks like it will be joining the Spring Cloud release train for Greenwich sometime next year. And at that point, they have to have Boot 2.0 features available for that. And like I said, there's a talk after this talk. Megan's going to talk about Spring Cloud or Kubernetes for the Spring developer. And I recommend that you stay and listen to her. And I can take a few questions. I think we have a couple of minutes left.